are live. Good evening, everyone. Welcome to our premium live chat for October 13th, 2022. We have a lot to talk about tonight. Of course, we have our cold front coming through that actually caused a cancellation, I guess, of the Yankee game, which is probably the best thing they could have done. And we're going to talk about the evolution of the frontal boundary and how we have kind of an example of phasing and not phasing in terms of timing with this cold front, which is very interesting and could possibly give us some indication of some of the challenges we're going to be dealing with in the upcoming cold season. But something I wanted to tackle and spend some time on is the influence of our volcano back in what was it? I think it was February. That has a lot of people interested to see what type of impacts it has on the upcoming winter. And there's a lot of stuff floating around out there, and I wanted to tackle this because it's going to be a major factor in the winter forecast in terms of forcing parameters, okay? And I've been studying this for months to try to figure out how does this impact the atmosphere, because if we don't have the understanding of this fundamental feature, then the whole winter forecast or the fall forecast or the tropical forecast is going to collapse. And we saw that with the tropical forecast. The failure of the tropical forecast has provided me a much better understanding of where we are in the atmosphere. And I'm going to show you a couple of features. It's not going to explain the winter forecast. We'll do that next week with the launch of the winter forecast. But this is such a significant and major topic that it deserved a time period all onto its own. So that way we better understand what is evolving with this atmospheric environment. So we start off first with, I want to show you some data from NASA here, and let's see, make sure I got this correct. There it is. Okay, good. All right, so this is from NASA. NASA.gov. If you Google it, it will pop right up. And what this shows you here is where we are in the atmosphere. This is around the Australian wildfires, and then this right here is the Tonga eruptions, okay, right around February. This right here is your water vapor. So let's hit play. And you can see this is a normal environment, and then boom, you see this evolution? See how it takes shape as we head towards September? Notice the key factor here. It's primarily focused over the southern hemisphere. There was an increase in water vapor in the atmosphere, in the stratosphere, by about 10%. Absolutely true. Now, there's some individuals running around saying, well, the water vapor is going to warm the atmosphere. And that's partially true. Yes, it will warm the atmosphere by about half a degree. The problem is that the water vapor, as you can see here, is mostly concentrated towards the mid-latitudes of the southern hemisphere. And so far, several months in, there's no indication of any dispersion towards the northern hemisphere as far as a significant portion. Nowhere near what we're seeing in the southern hemisphere. So while there will be a warming impact, it won't be uniform. So this idea that there'll be a blanket warming of the earth because of this, not exactly accurate because of where the volcano erupted and how the circulation in the atmosphere is evolving as a result. But we are seeing some interesting features here. And I start off first with the temperatures here in the southern hemisphere were very cold. Okay. Why is this important? Well, when water vapor is introduced into the atmosphere, what happens is that it interacts with ozone. And when that interaction occurs, it leads to rapid cooling of the atmosphere. That rapid cooling of the atmosphere leads to what we call contraction of the stratosphere and expansion of the troposphere. And that expansion of the troposphere leads to significant warming. Okay? So there's your warming influence right there. And you can see that also in the higher latitudes, but not as significant. Nowhere near as significant. It's primarily found in the mid-latitudes, between 25 and 36 south. So let's say Brazil, which happened to have a brutal winter, and portions of Australia and portions of southern Africa. Those locations. You can see here at 50 millibars, very cold environment in the mid-latitudes. Now this is all because this is where all the moisture has pulled. Notice at the same time at 50 and 30 millibars, in the higher latitudes in the southern hemisphere, you're nowhere near that cold because the water vapor is not pooling there. It's basically staying away from those regions. Meanwhile, let's see if we're having any type of impact like that in the northern hemisphere. Now remember, a rapid increase of moisture in the stratosphere will lead to rapid cooling and a tightening and intensification of the polar vortex. Are we seeing any type of cooling? Nope. In fact, we're near record highs. In the higher latitudes. How about the mid latitudes? Let's take a look at that. We are seeing some cooling, but nowhere near any type of record. Some cooling in place, but nothing too significant, nothing outside the bounds. Let's see 30 millibars. Again, pretty much slightly cool, but nothing too significant. How about the higher latitudes? Record high. Okay, so what's going on here? Let's go take a look at the globe. Okay, now this is the stratosphere, and these are the winds. And we have been talking about how the polar vortex here is relatively weak for this time of year. You can also see that at 70 millibars as well. Meanwhile, very strong down here. Here's what I think is happening. And this is my theory. I could be wrong, but this is what I'm thinking. Because of the buildup of mass, because you injected so much water vapor into the stratosphere, you have an imbalance in the atmosphere globally. And that global imbalance has to create a balance. And so you get this rapid cooling taking place. And let's take a look at the temperatures here. Okay. Very cold down here in the southern hemisphere. So there must be a balance in the northern hemisphere. And what I think is going to happen as a result of that balance is that you're going to have a polar vortex that is weaker as a result to counteract the influences that are happening in the southern hemisphere. This is a very unique event. It is very unusual. And usually what happens in the southern hemisphere has very, very little impact in the northern hemisphere, especially at the tropospheric level. But at the stratospheric level, there can be an imbalance and impact because you're putting so much mass in the southern hemisphere, you must have a counterbalance in the northern hemisphere. So I think that counterbalance is going to lead to a generally weaker polar vortex this winter outside of any of the other influences. And we've seen that so far. I think that's going to be continued. Don't be surprised to see the polar vortex strengthen a little bit as you move into November, because that should happen for this time of year. But I think it's going to be more susceptible to interruptions and a higher threat for high latitude blocking as a result. So that is where I'm at in terms of the volcano. I'll answer any questions that you might have going forward, but I think that's what we're seeing here in terms of the stratospheric influences. And this could also follow up for the ionosphere and mesosphere and locations higher up, where there was an increase by about 5%, but in terms of impacts on high latitude blocking, it's not really that strong. But in terms of influences on the interaction of the upper atmosphere with our satellites and whatnot, there has been a noted increase in disturbance and disruption in satellites. So if you have if you use cell phones or anything of that nature, you might be noticing more and more issues of late. That's probably one of the reasons why. Now, let's go back and talk about our cold front here. This is a very interesting scenario setting up here, because I was watching this evolution, and for a while there was an idea that, hey, look, widespread heavy rainfall. But notice we kind of have this separation taking place, okay, between very steady heavy rainfall over Long Island and Connecticut, somewhat into the Hudson River Valley. But then you have this break, and then you have your cold front, which showers training over eastern Pennsylvania, waiting for the cold front to approach. We zoom out. We have a wave of low pressure down here. Let me go back to our winds again. Go to 500 millibars, winds, and let's zoom in. Okay, so what's happening here? This is a perfect example of what happens when your phase is off by just 3 hours. 3 hours is the difference between a widespread heavy rainfall event and a low pressure system trying to race ahead of a cold front. What's happening here is that our disturbance in the subtropical jet stream, the southern branch, so to speak, here, I'll close this out, you can see it right here, is a little bit faster out ahead of the polar branch with this very impressive upper level low for this time of year and very impressive jet streak. Now, this setup leads to what we call divergence and diffluence. You see how the winds are kind of moving apart here, kind of spreading apart? Kind of think of it like taffy being pulled, and when you get that thin part of the taffy, air is trying to race up from the ground to fill that area of stretching. Again, conservation of mass. So your atmosphere is trying to fill that hole that's being stretched. And so that's essentially what's happening here, and that's why you have your showers break out. So you have this clear separation between the disturbance in the subtropical jet stream and your polar disturbance right here. And that shows up even more so at 850 millibars, where you have your clear 850 millibar low in the subtropical jet stream, racing out ahead of your upper level features back here with the polar jet stream. And that shows up very nicely on the water vapor satellite picture, if I can find the right one. Here we are. There's our disturbance in the subtropical jet stream. Here is our polar trough. If this was 3 hours slower, you would be talking about widespread rainfall, heavy rainfall for the entire region, and probably anywhere from 1 to 3 inches of rain. But because of the speed of this disturbance, what you end up with instead is heavy rainfall focused generally over Long Island, Connecticut, and much of New England. So again, this is why timing is key. You got all the other features in place to support a widespread heavy rainfall event, but the difference of 3 hours is basically what makes or breaks this storm. So what we can expect, based on the HRR, which is doing pretty well, is this wave of showers, heaviest over Connecticut and Long Island, and then additional showers moving in from west to east through early tomorrow morning. Here comes that phase that starts to take place. There's our low pressure system organizing. New England gets hit pretty good tomorrow morning, and we dry out thereafter. So that is essentially what is happening with our storm that we're setting up here, and that's why we have that separation. Finally, I just want to talk about Carl, Tropical Storm Carl. Let's refresh this real fast and put this on IR. Pretty impressive thunderstorms associated with Carl. The only problem is that the low-level center is here, and it's been getting sheared apart all day, and it actually weakened from its peak. It's now at about 45-mile-per-hour winds. Let's see if we can update this. See if we got any new data here. And yeah, still at 45-mile-per-hour winds, drifting to the south-southeast. Expected to make a landfall in Mexico. Not really a major threat for us, but it's interesting that Carl, first of all, was not expected to be a tropical storm. Even the NHC had an about 30% chance of forming into a tropical depression 2 days ago. So the reason why I bring that up is that sometimes you can't underestimate the power of a tropical low in the Bay of Campeche, because there's a ton of warm water there. And if you have any type of slight sliver of a chance of development, sometimes you end up with something like this. Thankfully, it won't impact the United States, but if you have any friends and family down in southern Mexico here, they're in for a rough time with some very impressive heavy rainfall. So with that, I am going to take some of your questions. Again, the setup for the forecast, should I say, release for the winter will be next week. What we're going to have here set up is I'm going to get the premium discussion done. This time I'm going to write it as a PDF that you can download. I'll see if I can just put it on the web page as well, but it's going to be a pretty, meaty discussion, going over all the features, all the factors, including what can go wrong. I haven't written it yet. I have it all in here and also in notes, and I probably look like a crazed mad scientist trying to figure out, trying to think to myself while I'm driving, like, okay, I want to do this, I want to do that, because sometimes you have your best thoughts when you're driving or taking a shower. That's actually medically proven to be true. So I've got the ideas all laid out, ready to roll. It's just a matter of writing everything out and trying to explain the best way I can what I think is going to happen and then what could go wrong in that forecast. So all that will be issued in the morning. The premium discussion will be issued for the premium members, and then in the evening, this time next week, we'll be launching the winter forecast with the public version, and we'll talk about it on here and take all your questions. So with that, let's take a look at the live chat discussion here. Let's see, of course, good evening card. A very interesting feature at 250 millibars in the Pacific. There's a cross-equatorial flow, mostly from the northern hemisphere to the southern hemisphere, east of Indonesia, looking at Earth New School. All right, let's take a look at it. You're saying 250 millibars. Okay. We'll zoom out here. Cross equatorial flow east of Indonesia. And this feature right here. This is part of the Hadley cell. This feature right here. That's what we're seeing. Pretty interesting stuff, right? Now, thus far, we haven't seen any real significant increase of transport from all that deep moisture towards the northern hemisphere. It's going to be interesting to see if that actually starts to really take place. But thus far, any info as to water vapor in the ionosphere and mesosphere and potential impacts of the same. The atmospheric features as far as our weather, that far up in the atmosphere, really is minor. The primary impacts in those levels really is driven by or influenced by what we have with our satellites. But I will say there was that 1 year, remember a couple of years ago, where actually it was 2019. Remember this 2019 where some air from the mesosphere bled into this stratosphere and just completely ruined the forecast for the polar vortex. Thus far, I have not seen any indication of that happening. It's been pretty much separated, so to speak. But I will, of course, keep an eye on that as we'll be continuing to watch any wild cards. Union County had some downpours, but otherwise moderate to light rainfall has been reported. Yep, for the most part. Did you see MLB calling the Yankees game this afternoon without even trying to get it in? Shocked they made the right weather decision for once. I would say I will applaud any improvement like that. I don't see the benefit of putting your best products out there in those weather conditions, i.e. your fans. Just postpone it one day. I mean, it's not like you gotta have to wait like a week or anything. So I was glad that they did that and they were proactive. So basically, the timing has potential to cause a lot of surprises one way or another this winter with minimal notice. Yeah, this is going to be a winter. I will definitely say this. This is going to be a winter where you cannot just say, oh, follow the GFS or follow the European, put a ball on it, call it a day. I don't think that we're going to be able to pull that off because I think we're going to be dealing with a weather pattern where the word phasing is going to be a constant phrase between the subtropical and polar jet streams. And when you have winters where you have phasing events, the timing of those phasing events sometimes can lock in and give you 3 or 4 winter storms in a row, or 3 and 4 misses with a lot of phantom storms and a lot of people posting 10-day GFS snowfall maps because it's putting out 30 inches of snow, and then you end up the day of the storm with some flurries. So it's going to be a real challenge, I think, going forward. I could definitely see that as being a theme with our forecast. Now I'll put the radar up while we're talking here and watch this evolution take place. Outstanding questions as always, guys. Did we escape the severe weather because the clouds with rain from earlier today? No, this was never really a major severe weather event in my eyes. There was the potential for strong winds because of the jet streak. Here, let me pull that up here, right here. So this jet streak was supposed to be over here by now, okay? The idea with the 850 millibar jet streak, as early as yesterday evening, was that this jet streak would lift up through New Jersey, head up into New England, and then lift northward. Instead, the jet streak has lifted through north central Pennsylvania, through central New York, and now into the St. Lawrence River Valley and portions of Maine. So that jet streak, combined with instability, was supposed to support a few isolated thunderstorms with the capability of producing some strong wind gusts, primarily driven by winds being mixed down from this jet streak. But in reality, that jet streak is nowhere to be seen because the phasing didn't happen in time, and so therefore the whole setup of the storm collapses. Over 1 inch of rain since 7 p.m. in Stewart's. That's pretty good. Hey, look, rainfall is good. The Weather Channel has us in above average during the winter. Okay. I'm going to do a rule this year for other winter weather forecasts. If the meteorologist isn't here to defend their ideas, I'm not going to critique their ideas. Because it's not fair, because we don't know what went into that forecast. Maybe they just went La Nina, copy paste, and that's it. Maybe they're putting more weight into water vapor influence. Maybe they just think that, hey, look, there's going to be a predominant ridge for whatever reason. I don't know. And if I don't know why they did what they did, then then it's not fair for me to critique it, because I don't know what caused them to do that forecast. 0.8 inches in Connecticut. So sorry about the Mets. Yeah. I don't know what to say about the Mets. That's a sore subject. That's going to take me about 6 months to get over. I can't even watch a baseball game. My eye starts twitching. I tried putting on. I made a mistake of accidentally putting on the Phillies Braves game, and they started to do that chant. I swear, my eye started to twitch so bad, I had to turn it off.
I will ply you with baked goods and things to try to comfort you.
I can't. I cannot watch baseball right now. And I had nothing against the Phillies or the Yankees fan bases. Enjoy yourselves. You guys deserve it. I don't know what to say. I'm rambling right now. I don't know what to say about that whole scenario. All I can say is, why didn't they just hit the ball? Just hit the ball. Please, just hit the ball. Okay, that's all I'm going to say. Based on what you are seeing, do you anticipate a shorter than expected hurricane season? We've seen a lot of shear this year, which is very un-La Nina-like. I think I can't rule out another tropical system trying to develop, but the potential is much lower than what we thought when we were going into this season. I'll put it that way. And I don't know why they just couldn't hit the ball. Anyway. In that, let's see here. In that situation, is there any particular tool that helps you get through that? For instance, the water vapor imagery. And then how about them Cowboys? So how about those Chiefs? Huh? Yeah, that's going to be a good game this weekend. Chiefs versus Bills. That's going to be a good one. In this situation, it kind of reminds me. I am not saying that we're going to have winter storms like 2009-10. I'm not saying that. It's not yet. What I am saying is that in that year, I relied primarily on comparing the water vapor to the model guidance and back and forth. And I got really good at doing that. What you do, let me pull up the water vapor satellite picture if I can find it around here somewhere. Here we are. Okay. This is what you do. You see this area right here of sinking air? This is what you want to watch. See, the more that you see this sinking air, the brighter colors it is. All right? And to me, it's white. To you, it might be yellow. When you see this bright colors, that means air is rapidly sinking. Knowing about the conservation of mass and energy, you know that if there's rapidly sinking air, there must be rapidly rising air. Now, how well does that correlate to what is being shown on the model guidance? So in other words, if you have a disturbance that has very strong PVA, a very strong lifting, there must be very strong sinking behind it in order to balance the atmosphere. So you make that comparison with the water vapor satellite picture, and by being able to pinpoint those areas you're seeing here, then you're also able to gauge the timing of it. You can calculate it as well using some calculations, okay, some meteorology calculations. I won't burden you with that, but you can definitely pull that off as well using the speed of the winds in the atmosphere, and you compare that to what the model guidance was saying. And what you want to do is that, let's say you have 0Z guidance, you want to wait until 06Z to start doing this. So give it a 6-hour lag time to see where is the model guidance compared to the actual observations. 12 hours is even better if you could do that. So if 0Z guidance comes out, this is why I don't stay up till like 2 a.m. to watch the latest European guidance come out, because it's useless to me. Same thing with the GFS coming out late. I mean, sometimes we'll do it just because it's fun, but in terms of operational meteorology, in terms of a forecast, I'm not going to change my forecast based on what just came out. What I want to do is give it a 6 to 12 hour lag time to see how well the model performs in that scenario and what errors are showing up and how those errors impact the forecast. So you use the water vapor satellite picture, you use your radar, you use your surface observations to all compare that and to work your way through that. Are there any upcoming MJO phases conducive to tropical development in the Atlantic? Not really. It's going to be stuck in phase 6, 7. It just... How do I want to put this? Okay, you know what? Here, I'll just show you this. There's nothing out there. The tropical waves moving over Africa are so disorganized, there's not even a low-level circulation. In fact, there's already vertical wind shear moving right into Africa. Vertical wind shear moving into Africa. Basically acting like a buzzsaw, cutting up anything. And we're basically in the phases we're going to be in. Moving into phase 6 and then to phase 7. Barely into phase 7. So, if we're going into phase 8 and 1, I'd say, yeah, maybe there's a chance. But this environment is as hostile as you could possibly get for October. I mean, you got shear here, you got dry air here. You have your tropical system, but even that is sheared apart. You can see the shear taking place. And look at the dry air trying to infiltrate the system, just pressing down. And on the water vapor, you can even see very deep dry air in the Caribbean. There's your shear factor. There's a polar air mass trying to drop south from Europe into northern Africa. I mean, if you wanted to find a hostile environment for tropical development, this is it. And ladies and gentlemen, this is La Nina. Does this look like a traditional La Nina to you? If for some of you who have followed me a long time, when we've had a traditional La Nina, did the atmospheric pattern ever look like this? Right? So, if you know La Nina is not acting like it normally does in the fall, why would you copy and paste that for the winter? Just think about that. Western Pacific. I haven't had a chance to really dive into the Western Pacific. Probably should. I've just been so, I guess you could call it burden, to really look at anything. But doesn't appear to be anything strong. Remember, in the tropical Pacific, when you're studying this, what we're looking for in terms of impacts are basically marginally maybe a Cat 2, but more so of a Cat 3, 4, and 5 to have any type of significant impact or to tell you anything about the pattern itself. So I'm not really seeing anything that really stands out to me in this environment so far. Let me check out YouTube. I can tell it's fall too because I got that itch in my throat. Can't ever get rid of it. It's like it makes like a dry cough. And you know what? Ever since, let's see, what was it? Since September, like late September. Yeah, late September. It just doesn't stop. I think it's an allergy, but I'm not sure. It's something. It's annoying, is what it is. It's almost as annoying as watching an entire baseball team forgetting how to hit for the last 2 weeks of the season.
All right.
It just bugs me. I don't know what to say.
Yes, but you're dwelling, and that doesn't help anything.
Yeah, I know. Yeah, the Indian Ocean's still cool, which is why I am very much confident that our La Nina is going to be steadily weakening as we move forward. Pardon me, I'm going to grab a lozenge before I start coughing all over the place.
You need something to drink?
Glass
of water or something?
I got water and I got everything else. My throat doesn't like me right now. Kind of like cleanup hitters who can't hit the ball because they're striking out because they're trying to hit 5-run home runs.
Alright, you stop it.
But La Nina this year, I think that we're going to start to see a steady weakening in La Nina. What's interesting is the SOI values. Because here's your SOI values, and they're pretty much steady for a moderate La Nina. But let me see. Here we are. Take a look at this. One of the things that you want to study when you're trying to find a change in the weather pattern, a major atmospheric change, is what you call the angular momentum, okay? So, angular momentum, and let me go to first the Canadian version. When it's negative, it supports La Nina. When it's positive, it supports more of El Nino. Now, when you start to see a change in the atmospheric forcing, that's kind of a nice little canary in the coal mine type scenario that major changes in the atmosphere are about to take place. So I've been keeping an eye on this, and the Canadian guidance goes slightly positive. Are you ready for the GFS? Very much positive towards the end of October into early November. What about the European guidance? Same thing. It's telling us a change is on the way. How about the long range European? This one goes out to 45 days. Wow. Isn't that interesting? This feature right here, tells us that there are changes in the atmosphere on the way, and that the steady state environment that we have with La Nina in terms of tropical forcing is not sustainable. And we've been saying that this isn't anything new or groundbreaking, because I've been saying that since the waters in the Indian Ocean cooled, because the primary forcing mechanism to drive your third La Nina wave, which in itself is rare, has broken down. And so since that broken down, it was only a matter of time until we start to see changes in the atmosphere. And we're starting to see those changes now. And as you can see with the model guidance, it's been trending more and more aggressive as we get closer to this event. And so that is essentially what we're seeing here, and why it is very, very interesting to see this evolution take place. So I've been using this, probably maybe this might be a little bit of a sneak peek into the winter forecast, but I've been using this to kind of craft my idea of how this atmosphere is going to look, how the major driving impacts of the atmosphere are going to interact with each other and play against each other. And so that's what I'm seeing here in this environment. Is that signal showing up? Here we have our rainfall event once again. You see our cold front coming in. Steady rainfall remaining over Long Island. Thank God they called that Yankee game, right? I mean, that is some very impressive heavy rainfall around the Bronx, around much of Queens and New York City, and just a nasty scenario there. I know the HRR was trying to play up the idea of maybe a break, but I'm glad they didn't bite on that and try to jump on that. Let's see here. And we are coming up 8:40. So if we have any more questions, I'll be happy to answer them. I'm pretty much got everything covered I wanted to cover for tonight in terms of the cold front, the evolution. I will say we will be heading in towards a warm-up with our weather pattern, driven by the MJO evolution. And really the bellwether for the fall weather pattern is the location of our upper level low over the Pacific. When it's in the Gulf of Alaska, it does this. We are going to warm up, and that's exactly what happens towards about the final 10 days of October. And then notice towards the end here, as we head right towards the end of the month, we see a signal once again of a returning upper level low towards the western portions of the Gulf of Alaska and the Aleutians. When it's in this position right here, anywhere from here to here, in this zone right here, if you have an upper level low or a trough here, you're going to end up with a trough in the east. And that's going to lead to a lot of storms and the potential for some pretty impressive high latitude blocking. And I think that is going to be a feature we're going to see quite a bit. Let's see one other thing. I wonder if this data is out yet. 1 second. The long range. Ah, yes. This just got updated. Perfect. This is the long range European. Now, the key factor is this feature right here. Look at the evolution. It shifts back towards the Aleutians. Boom, there's our trough in the east. And towards the end, this is a pretty impressive pattern for November, for late November. Trough around the Aleutians, ridge on the west coast, active subtropical jet stream, trough over the eastern United States, ridge signature around Greenland. Interesting pattern indeed. Wouldn't jump the gun yet. It has a bit of time before we see any type of verification out of this. But certainly some very interesting signals are showing up. So I will provide a detailed analysis on the winter forecast for next week. I'll answer all your questions, except for how much snow in your backyard. Because I don't know, and I don't want to be the jinx in that respect. But I think we'll call it a night. I'll get myself some green tea and get rid of this cough that is annoying the heck out of me. And of course, thank you again for coming in and following. I really appreciate it. Unless we have any other questions, I'll be happy to answer those. Doesn't look like it. So we'll call it a night, and I'll take care of this cough, and I will have the winter forecast ready for you next week. So as always, stay safe out there, and have a good night.